Subhash. Let me introduce myself. My name is John Hsieh. I've been at Cloudera since 2009, so that's 5 years now. That's quite a while. So how many of you guys have been playing with Hadoop or Big or HBase maybe in the past year? I guess hopefully most everybody. 2 years ago? Maybe 3 years ago? Ooh, 4 years ago? Oh wow, okay, we're getting pretty sparse over here. So what I'm going to try to do is I'm going to try to summarize kind of what I've seen from when I was in grad school working on this stuff kind of for research, and how it's become a little bit more mainstream. It's not quite there yet in my opinion, but how it's grown over the years, and maybe some hints as to where we're going to end up going. So as Subhash said, yeah, I'm at Cloudera. I'm the tech lead of the HBase team. I'm also the founder of a project called Apache Flume, which is one of the things in the stack that Kaz had mentioned. So really the way I kind of see it so far is that it's kind of broken down into 3 phases. There's this inspiration phase, and then there's this imitation phase, and then what I think we're in today is this innovation phase of how the stack has been evolving. So, you know, I started off learning how to ride a bike on one of these kind of things, and then the next step is to, you know, move up to the next level, get some training wheels, and I think this is actually where we are today in big data technology for the rest of us. Yeah. So let's first start about talk about the inspiration. Like, where did big data problems come from, and why do we have this whole big data field in the first place? One quote that I like is from 2010. Eric Schmidt, the former CEO of Google, said, every 2 days we create as much information as we did from the dawn of civilization up to 2003. I think the number back then was on the order of 1 or 2 exabytes a day, so every 2 days. And that number obviously, I think, has gone up in the past 4 years. So the amount of data that we have available to us is growing ridiculously fast. We also have our friend Michael Hayden from the NSA. You guys have heard this phrase over and over again, I'd imagine, volume, variety, and velocity. This was actually in his testimony to the Senate or something about talking about all the data that they had to deal with pre-9/11. And you know, the quote is, the volume, variety, and velocity of human communications makes our mission even more difficult each day. And I guess kind of based on what you guys have seen on the Snowden stuff or whatever, there's a lot of data that this organization was able to capture. So this is another kind of place where these big data technologies had this necessity. Really, both of these organizations, Google, government agencies, whatever, they're really doing a brute force solution with all the data. They're basically doing 3 steps. Collect all the data. In Google's case, let's download the web, all of it. And then we analyze the data, and then we turn it into something that we can serve useful information from. Right? So in Google's case, it is, you know, the search index, really useful stuff, right? But it really is a brute force solution. I think another very interesting thing is kind of the end of free megahertz, right? Computers stopped getting faster about I guess it's like 10 years ago now, roughly 2005, 2004, and you used to be able to just buy a new computer every 2 years and get it twice as fast, twice the capacity, and handle twice the data. But that free lunch kind of went away. And I think this very much coincides with the rise of big data and stacks like Google's and stacks like what are available today from Cloudera, Hortonworks, et cetera, the big data industry. And what this really has changed is the move towards distributed systems. Right? So all of these systems that we're talking about today at Big Data Camp are essentially distributed systems, and that brings new sets of problems and kind of a new way of attacking handling more and more data. This should be pretty clear. Like, all of these systems are going to use horizontal scalability to scale out. And a lot of them are going to talk about the challenges of dealing with reliability, fault tolerance, ACID consistency, high availability, and latency predictability. And those are kind of the systems that Lynn had talked about, and some of the evolution that Kaz and John Gray had talked about. So what did Google actually build? So this is based on stuff that they published back in 2003 or 2004. They kind of got to this problem first and published it first. they started off with three kinds of systems. They had GFS, which is their internal file system, massively scalable. They had a processing system called MapReduce, and they had a domain-specific language for processing logs called Sawzall. And then over time, they filled it out and they added kind of new projects and new kind of components around it, right? So you had Evenflow for managing processing jobs. You had a MySQL gateway for copying data from their old installations, which is the MySQL databases, onto this new platform. They used protobufs to manage all the different data to make sure it could be understood by all these systems. They created Bigtable for fast, low latency access, and they had Chubby for distributed coordination, right? So really, functionally, this is the pieces of the stack that we see today, but built in terms of Google's projects. So they kind of laid out the blueprint originally. But now we get to this phase, where early days for Cloudera and Hortonworks and whatnot, we were kind of in the imitation phase. This is one of my favorite quotes. The future is here already. It's just not evenly distributed. So, Google was far-sighted enough to publish their papers and kind of give us an idea of how they solve some of these really tough problems. And what we've done is we've taken those ideas and kind of built our own versions of them. So here's the Hadoop stack picture again, and one of the first companies to really take this and make it open for everybody, open source, is Yahoo, right? So they're the original sponsors of the Hadoop project, and instead of some of the systems that we have from Google, we have systems like Pig and Hive and Hadoop and HDFS and Zookeeper and HBase and Uzi, and the one that didn't get open source was a system called Data Highway. Facebook has a similar slide, LinkedIn has a similar slide. All these early large data web tech companies have their own version of the stack. And as you go forward in time, more of the pieces end up being the Apache pieces over time, right? So some of the systems that were originally built for Yahoo, like Peanuts, got essentially replaced by HBase later on. You can kind of see this thing happening with Facebook, and I didn't list everybody, but the point I want to get to is this imitation phase. We've gotten it to the point where we have open source systems for the rest of us, right? These are available for all of you all to download and use. The trend with all these systems is, what we do is we make it simple first. We get the core functionality that we need, and we make that piece scalable and simple and fast, right? So the example I have here is NoSQL databases. And what we've done is we've focused on one thing, at least in HBase. We focused on making single row transactions very fast, very correct, and very scalable. There are other systems out there. This is a very famous comic strip. I kind of censored it a little bit for the general audience, but it's still kind of complicated because there's one for every person. And this is actually kind of a problem that we have in this big data space because there's so many of these different systems out there. And what we've done in this imitation phase is actually imitate what Google has done. So there's a lot of these things that are missing, right? We don't have cross-table transactions. We don't have nice type schemas and enforced constraints on the data that we put into these systems. And I think that's why we're leading to today. And if you look at the efforts that are going today in the community and by the commercial vendors, it's in this innovation phase because I think this industry is stepping up. And I think it's going in a different direction than where Google and Facebook's are going. So let me give you this brief little timeline. A lot of these are kind of academic papers or announcements. Basically, the blueprints, let's say, that or Google or Facebook or some of these other companies initially published, right? That have become open source systems or have been cloned by open source projects. And what you can kind of see is that this GFS paper came out in 2003. Which means the system was probably built in 2001 and 2002. It's built a long time ago. And it wasn't until probably 2009 when Cloudera did their first release where it became publicly available. So there's a difference of 6 years there, right? And it's essentially a clone. This is piggybacking the work that a lot of other companies have done. As some of these other projects come in, like languages and ingestion streams and all these kinds of things, it's taken some time to catch up to where these proprietary systems were. So I would claim that by February 2012, when we did CDH4, that picture that I showed you in the previous section, we've kind of met that point. And I think one thing that's really interesting is More recently, the papers that we've seen from Google and Yahoo and Facebook are kind of going in a slightly different direction than where maybe Cloudera and the vendors are going, because there's a different set of problems that we need to solve for the rest of us. Right? So, big picture, I think Google is actually focusing on much grander scales than what I think the majority of folks need. They're dealing with data centers with hundreds of thousands of machines, and most users of Hadoop today are on the order of hundreds or thousands of machines. So, orders of magnitude difference. So where are the areas that we're focusing on today that might be different than where these pioneers have gone? I think one is usability, right? So Google had a paper called Tenzing where they talked about doing SQL on top of MapReduce, and Hive is very similar to that, but that was actually built and published by Facebook first. We have a system called Q to make a user interface, a shell, like so that you can actually access your data much like you would use in a Windows or Linux desktop. And then we have other engines now that fill in some of the holes that were missing in the original versions of the systems, right? So we have Impala for fast analytic queries. That's actually kind of a next generation after Dremel. And then we have other systems like Phoenix, Trifodian, and Splice Machine that are building the transactions that we've thrown away back into or back on top of HBase so that we can get closer to the old SQL that a lot of us are used to. And then there's other systems like Continuity, which are building in transactions, building in queues, and building in these other things to make it easier for normal developers to be able to use this technology. One other major place that we're going differently, I think, than like the Googles and whatnot is integration and security, right? Hadoop is being used by banks. Hadoop is being used by insurance companies. And Hadoop is being used by the medical community and drug companies. And there's much stricter regulations that go on with the data that's being stored at these locations. So the emphasis on security, if you guys followed the news, there are two acquisitions recently. Hortonworks bought XA Secure and Cloudera bought Kazang. And these are purchases of companies that provide, to make it easier to deal with security inside this big data stack. There's also projects like Apache Knox, Apache Sentry, and then the original Kerberos, adding Kerberos to Hadoop and HBase that kind of is a reflection of those requirements that are more important for us than necessarily for Google themselves. And then there's all these new directions that have come out. Those papers came out 10 years ago, and there's things that we're dealing with today that are completely different. We have AWS, we have the cloud, so a project that works on that, making it very easy to deploy there, is Apache Work. We have a new architecture for processing called Yarn. We have another substrate called Mesos, which is kind of a hypervisor for a cluster. And then we're also tackling more machine learning projects and open sourcing things to provide the algorithms for pattern matching, for recommendation engines and whatnot. So that's what Oryx is, and that's what the engine that Spark is providing, giving you the ability to do iterative processing to build your machine learning models more quickly and efficiently. So I really think I kind of want to end on this. Basically, I think we're going in a different direction than where Google has been focusing a lot of their efforts, or at least their papers and what they've been publishing. And I think we're in a really fun place right now because our future is going to be intersecting, but not exactly the same as what Google's and Facebook's are. The only really way you can predict the future is to just go build it yourself. So, we should get cracking. Thank you.